2 minutes.
Hi, my name is Batty. I've been asked to talk to you about cellular automata modelling and to some extent agent-based modelling. I've been involved in urban and regional modelling, that's applying various techniques of simulation and modelling to cities for a very long time. And in the 1980s, myself and Paul Longley, my colleague Paul Longley, were involved in developing ideas in complexity theory, particularly fractals, to the notion of how we would describe and simulate cities. Now, the essence of a fractal is that it relates to an object which is self-similar, its scale, so we can see the pattern in a fractal repeating itself at different scales, different spatial scales, for example. Also temporal scales. A very good example of this in a city is a shopping centre. So for example, you have small corner shops and then neighbourhood shopping centres, district shopping centres, and then big city centres and so on, in a kind of hierarchy where the functions are differentiated, but there is a self-similarity. Now, the methods for simulating self-similarity are essentially cellular automata methods. Cellular automata methods define the system as a series of cells, small elemental objects, and the cells themselves change state, they change their condition. If a cell is a land area or a parcel, it might change from urban to rural, or rural to urban, more likely in a sense, and the cell changes on the basis of what's in its immediate neighbourhood. So a cellular automata model essentially changes the state of the cell, of its cell, by looking at what's happening in the surrounding neighbourhood. Very strict cellular automata models, which began to be thought about in a city's context in the 1980s. Waldo Tobler wrote some interesting papers in the late 70s, and then Helen Clelis wrote a little bit in the mid-80s. We were involved in fractals at that point, and the cellular automata algorithm was used in terms of fractals. The idea is that we build up, as it were, structures which are things like cities and so on, from the ground up, bottom up, which is a principle in complexity theory. So we evolve the city really using these kind of cellular mechanisms. Now, what appears in cellular automata models are patterns at scales that are higher and greater than the scale at which the model operates in that sense, and therefore we think of these models as being generating urban development using essentially bottom-up types of mechanism. In cellular automata models, we also are able to impose other kinds of conditions relating to other groups of people operating in the city, developers and so on, which may not be bottom-up in a sense, but to some extent the whole spirit of cellular automata is to model the world from the bottom up. Now, there are many different packages. We've been involved in a simple package about 10 years ago called DUEM, Dynamic Urban Evolutionary Models, but there are many quite well-versed packages in cellular automata. Sleuth, for example, which is developed by Keith Clark in Santa Barbara, has been quite widely applied. A more elaborate set of tools, etc., relate to the work that Roger White and Guy Englund have done. The Metronamica models, which come out of Holland, basically have been quite widely applied and coupled to other kind of modelling schemes. Okay, I should just say a little bit about what we've been doing, really. We've worked on fractals, obviously, in the 1980s, and if you want to look at our book on fractals, then it's online. You can download it. www.fractalcities.org is the address, so you can actually download the book in that sense. In terms of cellular automata models, then I wrote a book, and I'll just show it you at this point. I wrote this book, Cities and Complexity, which is MIT Press, which is in print still. You can have a look at that. It really develops cellular automata and agent-based models. And more recently, in terms of agent-based models, you can think of cells as agents. Then this book, edited by Alison Heppenstall, Andrew Crooks, Linda C. and myself, essentially deals with sort of agent-based models. So cellular automata models have evolved, if you like, into slightly more sophisticated equivalents, which indeed are agent-based. If you want to get more information on this and download certain papers, then have a look at our CASA website, www.casa.ucl.ac, and have a look too at my own blogs, basically website blogs, which are www.cities sorry, let me say this again. www.complexcity, all one word, complexcity.info, and www.spatialcomplexity, all one word, .info. So those web resources will point you in the direction of papers that we've written, both here in CASA and me individually, from which you can find out a lot more information. Thank you.